Hello everyone. In this video we're going to be working on two more examples with rational inequalities. These are a little bit different just because you can't actually equal a vertical asymptote, so it's just an important thing to keep in mind when we're working with these equal to's. So let's start out same way we did before, so just factoring. I'm going to factor this numerator. 1 times negative 24 is negative 24. And I want two factors of negative 24 that add to give me the number in the middle, which is positive 2. Factors of negative 24 are 2 and 12, and then we also have 4 and 6, and 1 and 24, and 8 and 3. Yeah. So we're going to be using 4 and 6 to get to 2, so let's use positive 6 and negative 4. Since this does have a 1 in the front, we can go ahead and skip down to our factor form, so it's going to be x plus 6, x minus 4, and the denominator is already factored for us, so let's just leave it x plus 2. Okay, so we first want to talk about our vertical asymptotes, and we only have one vertical asymptote here, and it's what makes that 0, so that would be negative 2. And then we also have our x-intercepts, that's where the numerator is equal to 0, so essentially what factors are in the numerator, and we want to see what would make that 0, so it'd be negative 6 and positive 4. Okay, now the important thing to note here is that a vertical asymptote is actually a discontinuity, meaning you can never equal this point. Okay, so that's really important. And that's because that's a discontinuity. Remember, that's the vertical asymptote, the line that it can never touch. You can touch a horizontal asymptote, just not a vertical asymptote. So we can't ever touch that. So at the x equals negative 2, I have to draw an open circle, even though this is a greater than or equal to symbol. So let's draw our line here. And we're going to have the following points: negative 6, negative 2, and positive 4. And let's just go ahead and write out our circles or closed circles here. So at negative 2, since I can never equal a vertical asymptote, I have to draw an open circle there. Can't equal it. It has to be a point that doesn't actually exist right there, because we have that vertical line. Remember that it's never touching. Then at negative 6 and 4, these are x-intercepts, and since we do have that equal to right there, we definitely can touch those x-intercepts. So this is going to be a closed point here and a closed point here. Okay, now we can go through with our sign analysis. So I'm going to pick a point down in here, let's just say negative 7. Pick a point in here, let's just say negative 4. Pick a point there. I like to choose 0 if I have the option. And let's just pick a point over here, 77, because why not? So let's just see what we get over here. And we just want to know, is it a positive or is it a negative number? So I'm going to be plugging these points in for x, but I can also just use a table in Desmos, which is pretty quick, and it will get to the answer just the same way. Of course, you can do this in your head, but you can also use a calculator. It's pretty simple. Okay, so let's type in our factors here. And we want to divide all of this by x plus 2. And I just typed in the factor form. It doesn't actually matter which one you type in there. So let us plug in our points. I was looking at negative 7. I was also looking at negative 4. And then we're looking at 0 and 77. Okay, so looking here, we have negative 2.2, 8, negative 12, and 76.696. Okay, and all we really care about is this positive or negative. So this one was negative, positive, negative, positive. So we're going to do the same thing up here. Negative, positive, negative, positive. And looking back at the original, we wanted this to be greater than or equal to 0, so that's going to be a positive there. So since we're looking for its positive, that's going to be here and here. Okay, so we're going to write this our two different ways. The first way is using the inequality notation. So this is between -6 and 2. So x is between -6 and -2. It can equal -6, so I'm going to draw that equal to there, but it can't equal -2, so I'm not going to draw it there. And then we also have our interval over here, where x is just greater than or equal to 4. Okay, so that's one way we can write our answer. And the second way is using the interval notation. So this is saying it's between -6 and 2. It can equal -6. I'm going to draw a bracket there. It can't equal -2, so I'm going to draw parentheses. And then we also have the interval where it's greater than or equal to 4. So 4 to positive infinity. Okay, we're going to work out one more example, and then I feel like you guys will be okay with these problems. So let's try this top one up here. I'm going to factor first. 1 times 16 is 16. I want two factors of 16 that add to give me the number in the middle, which is positive 10. Factors of 16 are 4 and 4, and then we have 2 and 8. So we're going to use 2 and 8. Since we don't want in the front, we can jump to our factored form. And we have our denominator. And let's just leave this. Okay, x minus 8. Okay, so now we want to write out our vertical asymptotes, and we also want to write out our x-intercepts. Notice we only have one vertical asymptote here, so that's going to be at whatever makes that factor 0, so it'd be positive 8. And then we have two x-intercepts, that is where the numerator is equal to 0, so that's going to be -2 and -8. All right, so let's go ahead and draw our number line. And keeping in mind that we can actually never touch that vertical asymptote. And that would be the same thing with a hole right there if we had a hole. So let's go ahead and make our number line here. We have -8, -2, and positive 8. And I'm just going to test some points here. So I'm going to try one that's less. So let's try -9. One that's between those two. So let's try -5. One that's between these. So like 0 if it's there. And then 1 on the end. So let's just try a positive 9. And we just want to see, are these positive or are they negative? So let's take these and plug them back into our equation. Okay, so going back to Desmos, and I am just going to change what I have in here. So x plus 2 x plus 8, and then all of that is divided by x minus 8. Okay, so here is our function, and there we can see it a little bit better. All right, and I'm going to plug in my points. First one is -9, then we have -5, 0, and then positive 9. So let me just jot down these points. -0.4117, 0.692, -2, and then 187. Okay, we're only concerned with whether this is positive or negative. So this first one was negative, then positive, negative, then positive. So negative, positive, negative, positive. Okay, and just keeping in mind also that we can't equal our vertical asymptote. So at 8, I'm just going to go ahead and draw my open hole. But I can equal the rest because we have this equal to right here. Okay, and looking back at the original problem, we wanted to see where this was less than or equal to 0. So we're going to be looking for the negative part there. So I'm just going to shade the negative regions. Okay, so let's go ahead and write out our two answers. The first one, x is less than or equal to -8. So that's just anything that's less than -8. Or x is between -2 and 8. And it can equal the negative 2, can't equal the 8. So I'm just going to draw that little just less than sign there. Okay, and then the last one, the other way we can write it is the interval notation. So anything that's less than negative 8, aka from negative infinity to negative 8. And it can equal negative 8, so I'm going to draw a bracket. And then between negative 2 and 8. Or sorry, yeah, negative 2 and 8. And we can't equal 8, so we draw a little parentheses right there. Okay, if y'all have any questions, please feel free to reach out to me in your mind or however you talk to me. Okay, hope that you guys have a great rest of your day. Goodbye.